Okay, objective 6B for Honors Math 3. There's not really anything necessarily new in this lesson, but we're just going to take a look at a few kind of special examples. We're getting a chance to practice some more with vertical asymptotes, horizontal asymptotes, and then just the sketching of the function. So let's say that we have this function, rational function, y equals -2 over x plus 4 plus 1. Now, based on what we learned earlier in the semester, really, we could sketch the graph of this function, y equals -2 over x plus 4, and then the plus 1 just means that we're shifting the whole graph up 1. Now, we could deal with it that way. We could get a common denominator and create a single fraction. I would kind of like to look at it without doing the single, getting a common denominator and taking a look at it that way. Okay, so vertical asymptotes. Well, -4 is a real 0 in the denominator, and it causes a problem. So x equals -4 is vertical asymptote. Okay. Horizontal asymptote. If we take the limit as x goes to infinity. Now, we have a fraction here, and that fraction is bottom heavy. So the limit as x goes to infinity for that is 0. But there are no x's in that plus 1. So the fact that x is going to infinity is not affecting that at all. And so even though this part right here is 0, 0 plus 1 is 1, and so the horizontal asymptote is y equals 1. Okay, as far as x-intercepts go, we know we plug in 0 for the y. Now, when we have a single fraction equaling 0, you can essentially just look at the numerator. But if it's more than just a single fraction equaling 0, because I've got the plus 1, you can't just look at the numerator. You have to solve. So let's see, if the fraction is negative, I'll move it to the other side. So 2 over x plus 4 equals 1 over 1. I can cross multiply. So I get x plus 4 equals 2. And we get x equals -2. In other words, -2, 0. Okay, y-intercept. We know that y-intercept, if I plug in 0 for the x, we get y equals -2 over 0 plus 4. So -2 over 4, but plus 1. So that's -1/2 plus 1, so it's y equals 1/2. So 0, 1/2. Okay, well now we can go ahead and we can sketch the graph. And x equals -4. Y equals 1, horizontal asymptote. We've got -2, 0, and 0, 1/2. Okay, based on what we learned in the previous set of notes, I think it's pretty easy to see on the right-hand side of the vertical asymptote, we are coming from down low near the vertical asymptote and going towards elevation 1 as we go to the right forever. Label the intercepts. Now, that was my only x-intercept. So on the left-hand side, could I be coming from down low and going to elevation 1? No, there'd have to be an x-intercept. So I must be coming from up high going to elevation 1 as we go to the left. Okay, so that one's done. And now, an alternative, you could get a common denominator and create a single fraction, and then we do it just the way that we've been doing before, but you can see we can deal with it this way as well. Okay, next problem. Let's say we had y equals x minus x squared all over 2x minus 2. Okay, so we want to get it in factored form, obviously. So the denominator, you've got GCF of 2, and the numerator, you got a GCF of x. And we look at it and we go, oh, look, not common factors, but they are opposites, and so they would reduce, leaving behind a 1 and a negative 1. And so that actually reduces to negative 1/2 x, or negative x over 2. Okay, now don't forget the fact that a 0 that was in the denominator reduced. We have a whole at x equals 1. We want to know specifically where it's at, so 1 comma. If I input the 1 into the reduced equation, we would get negative 1/2. So I have a hole there. Now, here's something else that happened. Do I have any x's left in the denominator? No. Now, in the previous lesson, I mentioned to you that if there are no x's left in the denominator, there can be no asymptotes. So, vertical asymptotes? None. Horizontal asymptotes? None. We have a hole in the graph. How about x-intercepts? If I set this equal to 0, y equals 0, negative 1/2 x equals 0, wouldn't that be x equals 0? Yep, so 0, 0, which that's also a y-intercept too. Let's graph this. No asymptotes. I've got 0, 0. I've got a hole at 1, negative 1/2. And take a look. The equation reduced to y equals negative 1/2 x. And I realize I just plotted the point in the wrong place, didn't I? So 1, negative 1/2. Okay, now the equation is y equals negative 1/2 x, the reduced equation. Isn't that just a line with slope of negative 1/2? Yes. So it's just a line with a slope of negative 1/2, and there's a hole at x equals 1. Okay, label the intercepts, 0. Label the hole, 1, negative 1/2. And that one's done. Okay, third one. Y equals negative 2x over x squared plus 9. Okay, does the denominator factor? Well, I mean, everything can factor, but does it factor over the integers? No. Are there any zeros in there? Yes, there are 2 zeros in there. It's a second degree polynomial down there in the denominator. What would that equal? What would make it 0 down there? If I set that equal to 0, wouldn't we get x squared equals negative 9, so x equals plus or minus 3i? those aren't real zeros, are they? So vertical asymptotes are only where the real zeros are. There are no real zeros for the denominator. Therefore, there are no vertical asymptotes for this function. Are there any other types of asymptotes? Well, there could be, because we still have x's in the denominator. It didn't reduce. So what about horizontal? Well, it is bottom heavy, so the limit as x goes to infinity is 0, so y equals 0 is my horizontal asymptote. X-intercept. If I set y equal to 0, could this fraction equal to 0? Yes, if negative 2x equals 0. So x-intercept 0, 0. So if x equals 0, by the way, that's also a y-intercept. Okay, sketching this. Okay, we've got 0, 0. No vertical asymptote. We have a horizontal asymptote. Y equals 0. Now remember, I also told you that there's always one more piece of graph than there are vertical asymptotes. So since there are 0 vertical asymptotes, there's one piece of graph here. Okay, and we're going to have to plug in some points. So I'd suggest maybe plugging in a 1 and a negative 1 just to kind of see what's going on. Because as it goes to the left and right forever, the graph goes to elevation 0. So if we input maybe f of negative 1, so if I input a negative 1, negative 2 times negative 1 is positive. All I really need to know is positive or negative. Negative 1, if I square it, is positive, plus 9 is positive. Positive over positive is positive. So at negative 1, we're above the x-axis. Do the same thing at f of 1. So f of 1, if I input a 1, I get negative 2 times 1, that's negative. If I input positive 1 here in the denominator, we get 1 plus 9, which is positive, and negative over positive is negative. So at positive 1 for x, we have a negative y value. Okay, so we only have one x-intercept, which is also the y-intercept. As it goes to the infinities, it goes to elevation 0. On the left side, it's above the x-axis. On the right side, it's below the x-axis. So as I go to the right, it has to go through that point, but then it has to come back to the x-axis and go to elevation 0 from the bottom side. As I go to the left, it goes through that point and then goes to elevation 0 from the top side as it goes to the left. So there is that graph. That's kind of an interesting one too. Okay, thought we'd look at one more, and then you can have the rest of the time to be working on 4.6b. Y equals 2x squared minus x cubed all over x minus 2. Okay, so now we want to have it factored. So obviously the top has a GCF of x squared, and so x squared times 2 minus x over x minus 2. And we can see that those are opposites, the 2 minus x and the x minus 2. And so one of them's a 1 and the other one's a negative 1. We could have actually shown factoring out a GCF of negative x squared instead of positive x squared. But this works too. So really, this is negative x squared once we really reduce it. Y equals negative x squared, which is just simply a parabola opening down. But remember what the fact that the 0 in the denominator are reduced. So there's a whole at x equals 2, specifically at 2 comma, now plug in the 2 into the reduced equation, so 2 squared is 4 times -1, so 2 -4, whole at 2 -4. Okay, so let's see, are there any x's left in the denominator? No. So no asymptotes at all. So vertical asymptotes, none. Horizontal asymptotes, none. X-intercept, can, if y equals 0, then sure, x equals, so 0, 0. Okay, and so graphing this, got 0, 0, and we have a whole at 2, -4. And remember, it is just a parabola, so there's some symmetry stuff going on there. So -2, -4 would be another point that's on there. And it's doing something like this. Okay, label, there's 0. That's the origin right there. And here's my whole at 2, -4.